Sennheiser just released the MKH 8018, a new stereo shotgun mic with 3 switchable stereo modes, and I'm using it inside a blimp and a windscreen to record my voice today, but we also put it through its paces recording on-set audio and some light Foley for a short film. So dim the lights, get your popcorn ready, and enjoy.
Is a little bit of stillness too much to ask for?
The MKH 8018 is the latest addition to Sennheiser's MKH lineup, which are all about capturing sound authentically and with as much realism as possible. So it only made sense to use this mic on a film that highlights how everyday sounds can steal our focus. Aimed primarily at those who record audio on location, be it ambience for film or documentary, or even environmental sounds, the MKH 8018 is not your typical stereo shotgun mic. The MKH 8000 series as a whole have a couple of key differences that set them apart from other microphones, particularly when it comes to operating in harsh environments, which I'll get into in a minute. But first, the MKH 8018 has 3 stereo modes which are derived from the signals of 2 capsules, a supercardioid and a figure 8. You can essentially think of this mic as an MKH 8060 supercardioid mic and an MKH 8030 figure 8 mic combined into one microphone. This means it outputs 2 signals via a 5-pin XLR jack and breaks those out using Sennheiser's ACS5 XLR cable, which on a side note is an additional purchase. The supercardioid figure 8 arrangement is what creates the mid-side, or MS mode, where the supercardioid capsule provides the mid information and the figure 8 capsule provides the side information. These independent signals can then be mixed in post or in the field with a matrix mixer to determine the width of the stereo image. I used the mid-side mode for the majority of the on-set capture for the film because I wanted to have more control for the audio mix. Let's take a listen to a short clip recorded on-set, starting out with the mid-channel, and then I'll bring up the level of the sides in post, and you'll hear more of the ambience. The other two stereo modes are XY wide and XY narrow, which are internally matrixed down from the MS signal, the difference between the two being the amount of ambience present in the stereo signal overall. I used the XY wide mode to capture some traffic sounds that were used in the film. And in terms of other switches on the mic, there is a 70 Hz low-cut filter and a minus 10 dB pad. Well, okay, playtime's over, and now it's time for some serious business and a technical discussion about microphone operation and technology, and why this matters to location sound recordists. All of the mics in the MKH 8000 series achieve their high level of sensitivity and extended frequency range with the RF, or radio frequency condenser principle. Traditional AF, or audio frequency condenser designs, rely on a movable diaphragm positioned in front of a fixed backplate. When phantom power is applied as a DC polarizing voltage to this arrangement, the result is that the capsule becomes a capacitor. As the diaphragm vibrates in direct proportion to the changes in sound pressure from the incident sound, the capacitance varies accordingly, which causes current to move in or out of the capsule. This current is then measured by the internal head amplifier or preamplifier within the microphone to generate a stronger audio signal at the mic output. And while there's no doubt that this is a tried and true design, there is one major drawback that can have audible consequences, particularly in humid environments. The charge stored in the capacitor, or the capsule, has to be maintained at a constant level until the diaphragm moves, meaning that the internal head amplifier in the microphone needs to have an extremely high input impedance to avoid drawing current from the capsule. But the current from the capsule is always looking for ways to escape, and in high humidity, the stored charge will often escape on water molecules in the air, resulting in noisy and reduced output. Another drawback of the AF design is that the high biasing voltage needed for the capsule can attract dust and smoke particles, which can stick to the diaphragm, absorbing moisture, reducing linearity and efficiency, and can lead to crackling sounds. While RF condenser designs utilize the same basic capacitive capsule design, they employ it differently. The capsule operates in a low impedance mode as a tuning capacitor for an RF oscillator. While this is a more complicated arrangement, the low impedance nature of the circuit makes the capsule more moisture resistant, and the RF current flow naturally evaporates moisture, making this design more immune to the effects of humidity and thus well suited for outdoor recording. All of the MKH 8000 series microphones feature a symmetrical acoustically open push-pull transducer, which offers low self-noise, minimal nonlinear distortion, extended frequency response, and a consistent sound without off-axis coloration. Booming traditional XY and mid-side mic arrays can be a little cumbersome, so having an option that can fit on a grip and be mounted in a blimp is really handy. And while stereo shotguns are nothing new, the RF design of the MKH 8018 not only provides a realistic capture, but gives location sound operators a dependable mic to use outdoors in virtually any environment. But what do you think? Are you curious to test out the capabilities of the MKH 8018 on your next short film, documentary, or location shoot? Let us know in the comments below. Until next time, this has been Andrew for the B&H Pro Audio YouTube channel, reminding you to always remember audio.